Hi, everyone. Good morning, good evening, good afternoon. Welcome to our November session of Learning Labs. I'm Kirby from the marketing team here at Chainguard, and I'm joined by the awesome Patrick Smith, who's going to be running us through a Python image and securing your base image. I always ask everyone where they're tuning in from and to comment in the chat. But if you could also comment what you're most looking forward to learning from this session today, that would be really awesome. So we can see and make sure to cover all those points for you. From Texas, happy Tuesday. Good morning. Good morning to all of you too. And just a quick couple housekeeping items before we get started. You'll see on your right side, there's a chat where I'll be posting links when Patrick talks about links so that you guys can quickly access them. There's also a Q&A where you'll be able to ask questions. And if you don't see your question being answered, we'll just put it in that queue to make sure that Patrick addresses them. And I think with that, I'm just going to hand the stage right over to Patrick. Enjoy the session, everyone.
Awesome. Thank you, Kirby. Yeah, I'm really excited to share how to containerize a Python application with Chainguard Images, demo some cool stuff for you, talk about distro lists. Cool, we have some folks from Texas here. We just had our company summit down there, and I got to ride a mechanical bull. Can't say I'm that good at it, but maybe I should stick to the DevOps. But okay, let me switch over to the presentation, and we'll get started. So we want to share entire screen, always scary, but I like to have lots of windows. Okay. And all right, so welcome to our learning lab on Python. And my name's Patrick Smith. I'm staff developer relations engineer at Chainguard. In another life, I ran boot camps on data science at Columbia University. I've gotten to work with some cool other organizations like James Webb Space Telescope, SIGSTOR, Pandas. When I'm not doing learning labs for you guys or working on secure software, you can find me playing with my little daughter, Lily, or sitting in a freezing ice bath. I'm one of those guys. So what are we doing today? Okay, so we're going to talk first about the modern CVE ecosystem, what are CVEs, all that kind of stuff, why they're a problem. We are going to then switch over to where Chainguard fits into that equation and Chainguard Images. We are going to then build a small web application using the very cool Flask web framework in Python and containerize it using a Docker file I just found lying around the internet, kind of like a Docker file or example Docker file, and then check to see what kind of CVE situation we have when we do stuff like that. Then we'll switch over to using Chainguard as our base image and see what the situation is there. And we'll see how easy/hard or whatever it is to switch over to us in some situations. And then we will wrap up by doing a little bit more of a deep dive. We're going to do a multi-stage build using develop two image variants that we provide. And we'll talk a little bit about this concept that we like to talk about here at Chainguard distro lists and what are some of the advantages and so on there and some of the challenges. And then we'll have a little time for FAQ at the end, hopefully. So what do you need for this? You need a text editor of some kind. Or I don't know, I guess you could use here documents in Bash or something, but you need to be able to write files. You need to have access to some Bash or Bash-like environments. You will need to have Docker Engine. That is probably the most important thing. They will kind of expect you to be able to pull images, and we're going to use Docker build and Docker run. If you can do those two things, then you're probably going to be in pretty good shape. And you need a burning hatred of CVEs. Okay, so if you like CVEs, if you like having insecure software, maybe this is probably not the absolute best workshop for you, but maybe you can hate watch it or something like that. But we like secure software here. You will see me use Python a little bit, like Python on the command line. If you don't have Python installed or available on your path, you can skip that little bit section. That'll just be to show that the web application works and stuff. You can use Docker for the rest. All right, so we got our creepy little girl here to introduce the concept of CVEs. What are CVEs? I'm already using this acronym a lot. Maybe some of you haven't had your coffee yet. You're like, CVEs? They stand for common vulnerabilities and exposures. And essentially, these are known vulnerabilities that can affect software systems. So they're known. That means that they're tracked in a database, and a lot of providers also, release information. Upstream providers like Ubuntu, Red Hat, and so on will also be tracking these things. Us as well, Wolfie, Chainguard, and because they're known, they really should be remediated because people can look them up. People can look up if people look at your application, they can say, okay, well, looks like running this version of software. Let's look up, see what kind of vulnerabilities are available for that. So because they're known, they really should be remediated. And it's it's not just a security thing. It also is kind of a business use case thing increasingly these days because many clients, including the federal government, increasingly won't allow you to sell them software where you don't kind of say I'm gonna fix these CVEs after a certain amount of time, which makes sense because who wants insecure software really? However, there's kind of a problem, and that is that when you pull a image, container image, not naming any specific names, but when you pull container images from almost any provider, then you have an upstream problem. Because when you build your application on that software, on that language stack, platform, OS, then it comes along with a certain number of CVEs, often many, many CVEs. Could range from frequently, I would say more often than not, dozens to hundreds of CVEs. So you might write your own application code that's your area of specialization, solving your business use case. Maybe that creates 1, 2, 5 CVEs because of choices that you make. However, the majority of CVEs are going to be in those upstream providers. Okay, and then the question is, what are you supposed to do about that? Are you supposed to go in and fix the code for the Python ecosystem? Are you supposed to fix code for specific OSs? And the answer is, hey, that's actually really, well, that's not, I guess, impossible. It's impractical, and it's usually not worth it. And frequently, it's not even recommended, depending on the OS. So, where does Chainguard come into this? So, basically, we try to take care of that upstream for you. So we built, and we'll take a little step back in a second, but we have our own OS, which is Wolfie OS. It's open source, and it's a rolling OS where we're very focused on security, and we update frequently if new code comes out, remediating a CV, remediating some kind of problem in code. We often get that into Wolfie in 4 hours. Wolfie is designed specifically for container images, and those container images that we provide, Chainguard Images, they are built every night. So you get extra crispiness, extra freshness, and we fix things quickly. Okay. So who are we at Chainguard? Our motto is we're the safe source for open source. We start left. You might have heard the motto shift left, which means get a little bit further upstream when you're thinking about security, because you kind of have to these days. However, we start left. So we start at the beginning. We have our own OS. And when you work with us, you can kind of leave the upstream to us to some extent, or to a large extent. And we have a lot of security and DNA at Chainguard. Our founders are either big players or created projects like Sigstore, Kubernetes, DistroList. Okay, there's a whole long list of things that our people have worked on. Okay, so we're kind of security down to the bones. And Chainguard Images are secure and minimal container images. Okay, and they have some cool other stuff. I already said that we build them nightly. So they're built every night. You're not going to see those fixed CVEs in there at all. And we have some cool additional functionality. So we're going to talk about this more later. But we have different variants of our images for different purposes. So we have distro-less variants that are even more hardened than our low to no 0 CVE. And we'll talk about that number 0 in a second. I'll say 0 now, but we'll talk about it in a second. Or we have different variants of this low to no, or tilde 0, approximately 0 container images, and including the distro-less variants, which are even more hardened. And these images provide various other functionality, including we have Salsa, which maybe you've heard of, maybe you haven't, but software levels for software artifacts, and SBOMs, which basically is kind of like a manifest saying, hey, this is all the software that we're providing to you guys, and which can be quite useful for your own remediation, incident management, license management, all that kind of stuff. Okay, so we provide all that as well. So the images contain Chainguard Images is pretty state of the art, or we try to be. Now let's talk about that number 0. It's kind of a bit of a magic number. Okay, so and we say, we often say, hey, they're low. We try not to just be like it's 0 CVE, because sometimes you might pull a Chainguard image and maybe it has a CVE, 2 CVEs. It's a Tuesday, it has 2 CVEs. Generally speaking, you pull a Chainguard image and you scan it using a container scanner such as Trivy, Gripe, Docker Scout. We like all these scanners. And if you pull those and you look at it on any given day, chances are, if it's a day ends in Y, it's going to be 0. So, it's 0, but you never know. Stuff can happen. But let's look at a little bit of a historical comparison here. So we have the chart on the left is how many CVEs, known vulnerabilities, are in the upstream Python image. Okay, the Docker Python image, and so if you do Docker pull Python, that's basically that image. And unfortunately, it's a fair number of CVEs. So right here on this date that I just kind of included in here, it's October. It had 9. We're going to scan later. I believe it's up to 12. I would actually say 11, but Gripe counts it as 12. And so generally speaking, yeah, you're going to see a large number of CVEs in that official image. If you look on the right, this is a kind of non-chart of how many CVEs we've had in our Python Chainguard image during that time. And it doesn't look like anything because there's nothing on the chart. We haven't had any CVEs in that period of time. And this is using the Gripe container scanner. That's what we use for these comparisons. And just really quick, I can also pull up our page on this. So, and you can, maybe Kirby will share the link to this as well, our Python comparison, where you can actually, it's interactive. You can actually look at these CVEs. And we have a tab for the official image where you scroll, and you actually see plenty of CVEs, a lot. I don't even want to scroll to the bottom because it's too much time. And in Chainguard, we have, I think it's 2 actually. So, oh no, I think, are they unknown? So sometimes they come through. Yeah. So, yep. Yes. Let's see. I need to do F11. So 1, 2, 3, 4, 5, 6, 1, 2, 7, 8, 9, 10, 11. Okay, full screen. Did that do it? Oh shoot! Yeah, I see it. Sorry, my eyes aren't too good, so you'll see me now zooming in. Stop sharing. Oh, I hide. I got it. All right, cool, awesome. All right, now I'm permanently sharing my screen because I don't know where that button went. So you can't get rid of me now. Thank you guys. So yeah, so check out that page, and but so basically the question is, is this 0 number just marketing, and is it impossible to actually have 0 CVEs? And the answer is, it is possible. And then when we say that to people, they're like, well, first of all, well, if they're not being polite, they're like, is it a trick? Are you somehow fooling us? But the sort of more polite way to ask that question, I guess, is to say, how do you do it, right? And I guess if I have to do a one-word answer, well, first of all, people will say, is it the power of love? Did that what do it? And we say, no, it's not the power of love. Love is a very powerful, but it's not enough to remove all CVEs. It's actually really hard work. Okay, it's toil, and we have an amazing team of folks we have a CVE remediation team, an amazing team of engineers who have thought really hard about this problem. We also do it pretty smart, and we have a lot of infrastructure for this, but it also is ultimately a ton of hard work And we specialize in this, and we've hired all the best people in this area, and now you can't really have them back to fix your own CVs. So that's just how it works. But that's really what we do, is a lot of hard work. And specifically, what does that hard work look like? So it looks like because we're aiming for that 0, we care way more than anyone else really seems to about having minimal images, because we're targeting that 0 number. Every time we add a package to an image, it is potentially a source of CVEs over time. So we think really hard about that, and we only put in what's absolutely necessary, and we strip out a lot of stuff. And actually, we'll talk about distroless, but we go even further than you might even think reasonable with some of our image variants with that. Then, of course, we build every night, keep them fresh. We patch when necessary. Obviously, that's labor intensive, so that's what we do when we have to. And this is also a very important part of what we do, which is issue advisories. We have close relationships with scanners, and we work to advise them on how CVEs affect our images and whether or not they're relevant. Okay, so that's basically what that work looks like. Okay, so now we're going to switch over to demo. If people have questions about this part, go ahead, and I could stop for a second. But this will probably also answer some when you see. I think it's also, we're all people who actually like to do things here, hopefully, and build things. So sometimes I think seeing things in action answers a lot of questions. So, but we will hopefully have time for FAQ too at the end. But if any questions are in there now, I could take a quick. Okay, I'm not hearing anything from Kirby, so. Yeah. That's an awesome question. So, and we can answer that up top. Basically, the question was, which is a great question. Who asked that question? I like to call people out when possible, because it's fun. Okay, well, the name has a lot of personality, so we're probably not going to say it on the recording. But I laughed at it. So, but the basically question was, do we run as non-root by default? And the short answer is, for 97% of our images, yes. There's a few images I think that are exceptions to that for very specific ecosystem reasons, but basically whenever reasonable or possible, we run our images as non-root by default. So yeah, if you want to do certain things with our images, you're going to have to switch to user root or add that parameter when you're running them interactively. And but yeah, for increased security, we run our images as non-root, and that's a great question. Cool. We'll switch over to doing demo now. So if you go to this following link here, so it's golinks.chainguard.dev and /Python-migration. Okay. And Kirby is also going to share this link in the chat, and this will bring you to a GitHub repo where you will see a bunch of it has different branches for different versions of the project, and I have links to the different branches in the README, so you can check it out there. But basically, there's 3 main versions, and we probably won't be able to get to the last one, but it is kind of a more fancy Docker Compose with multiple components. So if you have time later or you're interested in this, you can check that out. But we're going to get through the first 2 branches there in this tutorial. And if you want the code, you don't want to type, then you can use that code for reference and copy and paste. Okay. All right. So moving over to demo, we've got the command line here. So I am using Z shell here, so it doesn't have the $, but this is your old familiar, very very similar. I don't think it should cause any problems. I'm personally a Z shell guy, but I'm going to head to a projects folder. This is optional, but maybe you have your own version of this. You have a folder where you create a lot of test stuff or whatever. So head to that, and we're going to create a project for this. So mkdir, we'll call this LL. I'll call it Learning Lab. I'll just call it Learning Lab. Okay. And we'll head into Learning Lab, CD Learning Lab, and now we've got our nice folder for this. Okay. So let's start by, I'm going to open my text editor, which happens to be Emacs, because, in addition to liking ice baths and punishing myself that way, I like to punish myself by using Emacs. But open VS Code or whatever, And we're going to start writing a file called app.py in here, app.py. For me, this is the E is just Emacs. Okay, it's an alias to Emacs. So, all right. So I'm going to write that because it's only a few lines. I'm just going to write it out, and then you'll know what it does, and it's kind of fun. So we're going to be writing a web application in Flask. So it's a micro framework in Python. I personally, I'm a big fan of Flask. I've used it for a lot of projects. Doesn't have a lot of boilerplate and stuff. And yeah, and we're going to be building a one root application that just basically displays some text. Okay. So from Flask import Flask and app equals Flask name. Okay, so that's our application object. Now we're going to create our root. Okay, so at app.root, this basically says, hey, when you go to this address in the browser, so it's going to be / or home, run this function def index, open close, and then let's just do return test. We'll add something a little fancier to this, but I just want to make sure everything works first before we overcomplicate things. And then if name equals main. This always confuses people, but basically it means only run this if you're running the script directly. Don't run it if you import the script. App.run. All right, and then we'll see what kind of fun mistakes I've made. So I'm just going to do, now we have to install Flask. Okay, so actually I'll also make a requirements.txt file that we'll use throughout this. So, and we'll also see if I can spell requirements. So this is less confusing. I need to do it this way. EREQUIREMENTS.txt. And we're just putting Flask in. So it's just going to say Flask, Flask. So you can see. Now, I recommend when you're actually building applications out there in the world, you pin your dependencies for a bunch of different reasons. But for now, we're not going to. Okay. So you want to do Flask equals whatever actual version you want. Okay. Be explicit. Being explicit is good. All right, so now we're going to create a virtual environment and install our one dependency. So we'll do Python. You can skip this step if you don't have Python installed on whatever machine you're using, because we're going to be switching over to Docker in a second. I just want to show you that this works. Then Vin. So I'm creating a virtual environment folder called Ven Vite for virtual environment. I'm going to activate it. Source Ven bin activate. And then we're going to do pip install flag r requirements.txt, okay, to install our one dependency. All right, and then hopefully this works. We'll see what kind of fun syntax errors or whatever to embarrass myself. Well, miraculously it worked, and it's running. So it's running this development server on port 5000. I'm going to open the browser, which opened, of course, behind everything else because Linux reasons. And we'll go to local host 5000. And it works. So it says test. And because we're going to be looking at this a couple times, we're going to containerize this a couple different ways. And because because I like to be annoying, I'm going to make this a little fancier. So I'm going to say octopuses. So we're kind of obsessed with octopuses at Chainguard because our upstream OS, Wolfie, we try to be very small and minimal, and Wolfie is the smallest octopus in the world. So Wolfie is kind of our mascot, and we have our logo octopus is called Blinky. So we'll use that here. So octopuses, and let's make 30 octopuses. Octopuses times 30, and then let's swap this out. We'll say H1 Linky, that's our logo octopus, is best. H1, and we'll do a paragraph and say octopuses. Okay, so we're gonna do a string formatting there, and then and then we need to make this an F string, which I started doing Python back when they didn't have F strings back in the dark ages, and you need to do string interpolation. Very painful. All right, let's check out the browser and see if that updated. It's going to allow me to actually switch. All right, I'll open a new one. Yeah, it's not like it's the Chrome. All right, let's switch over here and then, okay, there we go. Yeah, I'll do it again. It didn't like something I did. Okay, there's our app. Linky is best. We've got 30 octopuses all lined up because we like to have a nice proportional number of octopuses. Let's hide this thing now that I know where it is. Shouldn't take too long. There we go. Perfect. All right. And so that's our app that we're going to use. It's going to be this Linky is best app. Let's go ahead and containerize it now using sort of a random, and I did this on purpose, but like I just kind of want a Docker file that you might just find lying around the internet. You know, like I actually copied this from like the first blog post that come up on Google. Okay, so Docker file. We're creating a new Docker file, and I'm not going to write it all out here, but we'll go through it. So we have this Docker file, sort of random. It's pretty short. Basically, what it does is sets the working directory, and then it weirdly copies explicitly the requirements and runs it, but then it copies everything else over, which is kind of pointless. And then it installs our dependency, and then it runs the application down here, okay, with the CMD. So it's fairly standard containerization for something like this. So I'm going to save this. And now let's go ahead and build using this. And now this Docker file, remember, and perhaps Kirby can share to that first, I have that link there to the first Docker file. And you can share that so you can take a look on GitHub and copy this in if you want to follow along, okay? So let's do, it should be the one after the first one, Kirby's asking me. Should be the first one right after the Go links. Yeah. Cool. And then you can share that. That will be a link to the GitHub repo. So you'll have to look in the see the Docker file in the files and take a look at that. So let's do Docker build this folder, and let's tag it basic Flask. That's kind of what I'm going for here. And you'll notice it uses the official Python image here, so as your base image. So it's building. You see it installing our dependency, Flask. Okay, it completed. So let's do Docker run, and then we have to set the port. So expose the port on the host machine, and I called it basic Flask. All right, so now this is our containers application running. It should be exposed on the host. And then here, I'll open this just to show. Okay, and my calendar. Local host 5000. All right, so there's our containerized application. And now what we want to do is check how many CVEs this has, okay? So if you haven't used it before, it's a very cool utility. Actually, and I should deactivate the virtual environment. I'm actually going to delete it, okay, because we don't need it anymore. All right, so we're going to check using Gripe. This is a very cool project that is a container scanner. Basically, it will scan your container and tell you how many CVEs you have. And we made our tag was basic Flask. So we'll get this going. So it's going to take a second. It's going to scan this, and it tells us, how many executables, packages, and files are in the image. It also tells us how many CVEs it detects. And we like all the scanners. We like the Docker Scout. We like Trivy, but for our own, CI and everything, we use Gripe. So there's actually a ton of, unfortunately, of CVEs, and it's so many that I don't even want to scroll all the way up to get to the summary. So I'm going to redirect and run it again. Okay, but it's quite a few, and I believe from memory, just checking it this morning, I think it's going to say 12 critical CVEs, which is, if you're not familiar with how CVEs work, there's basically 4 varieties. You've got your critical CVEs that need to be urgently fixed. You've got high, medium, and low CVEs. And high can also be pretty damaging in the right circumstances, a little more situational. So in the summary, yeah, so we actually have some fixed ones there. So that, fixed, you're not going to see typically in Chainguard images because we build nightly. 12 critical and 105 high. So that's it's fairly rough. Now, you might say, oh, well, not all those CVEs are going to affect any given application. Some of them might be totally relevant. Yeah, that's totally true. Even if you said 1% of those is relevant, that's a pretty serious problem. And the other problem is that this is a huge amount of chaff, right? This is like a huge amount of, a lot of hay, not a lot of needle, if that makes sense. So the fact that all of these are in there means you have to go through all of those to figure out which are relevant, which aren't, and which is a huge issue. Oh yeah, it's a good time for questions. Yeah, and this question was basically, are we going to do a learning lab on Melange? And Melange is basically a tool that we've created to package up things for Alpine, and we use it for our upstream OS Wolfie, and we use it in concert with a tool called AppCo. Yeah, it may be, if if people ask for stuff, we will do something on it. So. And we have a bunch of resources on those upstream tools that you can check out too. So, and then was there one other question, Kirby? Oh yeah. Anything unique about Gripe, basically, was the question, which is kind of a fun question. And actually, I'm kind of planning on writing a blog post about this because it's something that comes up a lot. But I would say they'd have different strengths. So Trivy is kind of a kitchen sink sort of scanner, and it does a whole bunch of other things. So it'll scan your Kubernetes cluster. It'll scan various kinds of software artifacts. I find Trivy, it's a little bit of a heavyweight tool because it does so much. The output is a little it's very in-depth but a little unreadable. I kind of like Gripe for like a daily driver, and I also like Gripe in CI because in my experience it kind of doesn't fall over quite as much. It uses fewer resources. And for example, I was scanning an image, official image for the Nemo AI framework that is created by NVIDIA, which is like 40 gigabytes on disk. And the other scanners were kind of like falling over a lot with that. But Gripe actually took like 40 minutes, but Gripe did scan it and return results. So that's kind of impressive. And yeah, so I don't know. I'd say they're all pretty good. Docker Scout has prettier output. and actually, I will say a downside of Gripe is that I find its output to be a little, it makes sense, but it can be a little unintuitive the way it counts CVEs. Okay, and you can check out GitHub issues and stuff in there and for some conversation on that, but that can be a little unintuitive. So yeah, that's just my thoughts. Okay, so but they're all actually quite good, and I would say it's good to have a bunch of them in your tool belt. And we use all of them here at Chainguard. We just go reach for Gripe first pretty frequently, and that's what we use in our CI. Okay, so we basically found out, okay, we built this, we connected this application, we have a lot of CVE in there. Let's switch two small things. And yeah, trying to get my Emacs back up. There we go. So let's switch two small things, and we're going to switch the base image. So instead of the official Python, we'll do cgr.dev/chainguard /Python : and then the tag is going to be latest-dev, and we'll talk about that. We'll talk about that tag in a minute and what that means. Basically, we have different variants for different things. We have to change one other thing, and that is that we need to change the entry point to not have Python explicitly here because we treat entry points a little bit differently, and Python is the entry point by default. We don't do that kind of fancy script thing, and this is popping back up, so I guess I need to hide it again. We don't do the script that changes the entry point based on different things because we feel it adds unnecessary complexity. So basically, you treat the entry point as Python, okay? And let's rebuild. So we're going to do Docker build. And we'll tag it CG for Chainguard Flask. Okay, build. Okay, it worked. Docker run, and we'll do CG Flask. Oh, and we need to do the ports. 5, 1, 2, 3, 5, 1, 2, 3. Okay. Okay, it's containerized, it's running. It's running now on the Chainguard base image. We changed two lines. We changed the base image and we changed the entry point because of, we handle that a little bit differently. And just to be explicit about this, because this is just seeing the cache version, I'm reopening it. Localhost 5000, and it's working. Now let's do the scanner. Okay, so gripe cg-flask. I'm not going to redirect because hopefully I believe it's going to have significantly less output. Okay, and we'll see. Yeah, so today it is a day that ends in Y, but like sometimes, last time I did the learning lab, it had a few unknowns, which means that CVEs that are currently under analysis. So you will see stuff here sometimes. But right now we don't have any CVEs currently in our base image. So and because we haven't introduced any in the app, then we don't have any CVEs. So that's pretty cool. So what we're going to do next, and then this will kind of finish this out, is I want to create a multi-stage build that uses two of our variants. And the two variants are that we kind of sometimes use different words for them, but basically we have a distroless variant, so a hardened variant of our images that uses the distroless philosophy. Basically means we do not include things like shells, so bash, for example, bash, package managers, and then we try to go a little further and remove any other files that we possibly can. And basically the idea is to get the image as minimal and hardened as possible, and to remove certain categories of software that are typically add a bunch of surface area to your or attack surface to your application. So let's go ahead and create that Docker file, and then and we also use a latest. We have and that we tag those latest. So if you pull any of our images without a tag, it's going to be our hardened version. And then we also provide a latest-dev tag, which provides a version of our containers that has all those affordances. So it has package managers, it has shells, and so on. And we'll talk a little bit about the problems that can create for debugging and stuff right before we end. But so let's go ahead and do the multi-stage build. So I'm going to erase this Docker file. Start from scratch, and now kind of upgrading this a little bit. So before moving forward, I'm going to add to our requirements.txt one other item, which is this G-Unicorn, which is a little bit of a fancier server, because we're getting a little closer to actually being like an actual app here. So I'm adding that requirement, and then I'm also going to change out the Docker file. And you'll find this example Docker file in the, let's see, there we go. Cool. I believe this is the multi-stage. Okay, So you'll find this example one in the Python only branch in our example repo. So Kirby, if you could share that second GitHub link. Yeah, multi-stage build. Thank you so much. Okay, so I'm going to step through it with you guys before we build it. So basically, and remember we did add that one other dependency, which is G-Unicorn, green unicorn, that server. All right, so first of all, we start with our base image for the build. We have a build. Basically, you can think of it as a build process, and then that builds our software artifacts, and then we copy those software artifacts, which in this case is a virtual environment. We copy them over to the production variant, and then set our entry point or whatever. So so we use our development in the first stage to build the software artifacts, because we have pip and so on included, and then in the final version we copy it over to the version that doesn't have any of the variant, that doesn't have any of those things, that doesn't have pip and so on, doesn't have a shell, and then in order to run the application. So all right, so and you'll notice the tag here, it's latest dev, and we just call it dev. So for here, just stepping through it, we set the working environment, we create a virtual environment, we set the path so that to use the new virtual environment that we created, We install the software from the requirements.txt, and at that point, we have a nice virtual, in that container, we have a nice virtual environment folder. Then in the next stage, we use our production image, that this distro-list image. It doesn't have shells, doesn't have package managers. And then we copy over that virtual environment to this variant, then we have to set the path, overwrite it, and then expose the port. We're using 8,000 in this case, and set the entry point. Okay, actually, in fact, this is just metadata, but it's good practice. And okay, so, and we typically use entry point like this. You could do CMD here too and leave off Python. Okay, but we find often this is more explicit to set the entry point like this. Okay, and being explicit is good, less confusing. All right, so let's go ahead and build this. And remember, this is in that Python only branch, so you could follow along. And we updated the requirements.txt to add gunicorn, and then we switched out this Docker file for the multi-stage build. So Docker build, and let's tag this one CG multi-stage. Okay. So it's building. It's installing our requirements. Okay. And then let's go ahead and run it. So it's port 8000 this time. Docker run p8123 8123, and what did I call that? CG multi-stage. So now we are running the server. Surprisingly few issues today, but usually I like to have a few, problems, syntax errors, just to keep everyone on their toes. So this time we're going to do port 0.0.0.0 8000. That might have hit 0 one too many times there. Colon 8123. All right. And then we have our application running. Awesome. Now we're going to do a little bit of a different comparison. Okay. So this time I want to compare. We already know it's going to be 0 CVEs because we're now, the final built version of the image uses our hardened distro-less image. So it's actually, it's going to definitely have, if anything, fewer CVEs. And using the dev image, it had 0 CVEs already. So we're not even worried about that. But I want to show you a package comparison. Okay. So if we do gripe, and what did I call the original one? This is the original one we did, basic Flask CVEs. So let's just look. What I want to show you is the packages number here. So we're basically, instead of doing a comparison of CVEs, we're going to do a comparison of attack surface. And packages is a sort of, it's not, there's problems with looking at things like executable files, packages, but it does give you some signal on your surface area. Okay, it's not a perfect representation, but it definitely tells you something. So let's look. Packages, 459. Okay, so that's how many packages are in there. And actually, we could use Gripe's sister tool, Sift, and it would list all of the packages, which is pretty cool, but we won't do that. But if you want to actually see what all packages are in these images, you could use Sift, SYFT, and it will list all of them out. And you might even be like, why is that included? Why is that included? Because not all of them necessarily need to be included. So let's now do our Gripe. Do gripe, and then let's do the one we built before. Okay, CG Flask. Okay, so this is one uses our development image. Okay, and it will tell us how many packages this app built on our development image uses. And you'll see it's going to be a very big improvement. So 106 packages. So that is 75% reduction. It's many fewer packages. That's a lot less attack surface. That also means that, if you're concerned about not just known vulnerabilities, but unknown vulnerabilities, reducing packages can definitely help with that. Okay. So that's our developer. That's the application built on our developer variant. Now let's check it built on our distro-less variant, CG multi-stage. And you'll notice it's even smaller, 41. So we got it down really far. Now, how do we get it down that far? We remove things like the shell. There's no bat. You're not going to see ash, bash, sh. You're not going to see apk. You're not going to see pip. So that's a lot fewer things. Now you might reasonably say, hey, like that's great, but isn't it hard to kind of work with these images, debug these images if they have so if they don't have a shell, you can't just pull up a shell and like check things out. And I'm going to tell you, yeah, it's not actually, it does make things harder. However, the distroless ecosystem is getting pretty mature. And we do have some more tools than we used to in this area. So one tool we really like is cdebug. So you could check that out. If you have access to a Docker Pro account, then Docker debug is a very robust tool for like getting access to a shell in a distroless image. It kind of sideloads things. Most of these tools will sort of sideload things in. But also you can use our developer variant because that's what it's there for. Partly, it will help you debug these distroless images, and we try to keep them very similar, except for removing these items. So often, if you can get things working with our latest dev variant, that will be enough to get it working with latest. Okay. Cool. Okay. So, but check out these projects if you want to go a little further down this rabbit hole. I think that kind of brings us to the end here, except that we have some FAQ. So if I go back to, probably we'll have, I think the distroless stuff, probably people will have images, will have questions. So now this is Wolfie, or the tiniest octopus in the world, a fairly rare video because this octopus is only about half the size of your fingernail. And he's digging a little hole and disappearing. So so we'll leave him up while we have some FAQ. Okay. Okay. Yeah. Our friend with the cool name is raising their hand, or the name with the name that I'm not going to say out loud. Go ahead. Do we want to ask on the mic, Kirby, or do we want to? Okay, cool. Good to meet you.
Hi, yeah, you can just call me Chad. That's my
Okay,
actual name.
awesome. Okay.
Yeah, so earlier I asked if some of the Chainguard images run as non-root, and by default most of them do, which is awesome. However, an issue that I'm running into pretty much constantly with any rootless image is that if the user needs to bind mount to the host, so mounting like an actual directory rather than like a Docker managed volume, the user ID pretty much never lines up with the user ID on the host. How do you deal with that? Is that something that is not necessarily a solved problem, or do we just force people to use Docker volumes?
Well, yes. I mean, it is an issue. I would say, yeah, volumes is kind of the short version. We have some. If you drop us a line, so our customers run into some issues with this pretty frequently. We have ways of dealing with this. We are actually working on building some more infrastructure in this area that we're going to be very excited to talk about, but which will hopefully make this much less painful. However, if you're interested, you could drop us a line and I can share some of the stuff that we share with customers to get around this issue and do bind mounts. Because this is actually, the bind mounts is something we actually sometimes use fairly extensively for doing things like sometimes customers need to install different packages to distroless images. So there's a kind of a bind mount way around that, where we just install all the APK stuff. And then, so it's actually something we use fairly extensively. So if you drop us a line, I can share some of that stuff. It can be a bit messy, so so that's why yeah.
That's really clever using bind mounts for the install packages. Yeah, who should I reach out to?
You can reach out to Kirby, and then Kirby will reach out to me.
Awesome.
Do you have
Thanks,
the email there, Kirby? Yeah, awesome. Thank you. And yeah, but there's a couple of ways you can kind of get around the limitation, temporarily. But that's one way. It's definitely messy and kind of something we're looking into in a pretty serious way. So hopefully we'll have stuff. But cool, a great question. Anything else come up while we were talking about that, Kirby? We love you guys, Optum. Yeah. So Derek from Optum says, is giving us a little shout out there and how we create value. And Optum, I think I'm allowed to say, I think we've public about this, is one of our customers, and we love working with you guys. So thank you. Oh, this is a really exciting one, actually. So we have our upcoming learning lab. We've actually, this is going to be a new one. And we've created something very cool, which is our kernel independent FIPS images. So, and just to give background on what that is, FIPS is basically a framework for the federal government to approve or disapprove specific algorithms that are considered either secure or insecure. And you need to be FIPS approved to do things like FedRAMP, which will allow you to work with the federal government in different ways. And often, or almost always, you need to have the FIPS implementation requires specific kernel to be available to do the random number generation. And but because we're so container focused, that kind of causes certain kinds of problems and then requires certain kind of hosts, et cetera, et cetera. So we've actually been working for a while on a kernel independent FIPS implementation, and one of our engineers, Dimitri, has created something very cool, which is basically kind of resolves that kernel requirement issue. And we're going to be doing a learning lab with my colleague Adrian Moat, who is a Docker captain, and he will walk us through that next month. So I'm very, very excited about that, and I will be attending certainly.
Yeah.
Cool.
Well,
anything else, Kirby?
Yeah, I don't think I see anything else. Do we have any more final questions? Hi, everyone.
One more meme here.
Producer is back. I told everyone that you're talking to yourself because I'm in your ear, but nobody can hear me. So.
Yeah. So yeah, if people are wondering why I'm talking to myself, it's just Kirby. Kirby, the presenter, is talking into my ear like a little DAEMON on my shoulder.
Yes. We have another question come in from Mac. What pain point usually leads customers to switch from the open source to paid images?
Okay, that's an interesting question. Mac asks, what pain point typically gets customers to switch from our open images to paid images? I would say there's a bunch of things. I will just throw out two of the big ones. One is if you need older tags, which will come up pretty often. It can be hard to keep a production system going, and we will only provide you with the latest variant. So basically, you kind of have forced upgrades a little bit. It's always great to use the latest and greatest, but sometimes you'll have a business reason that you need to stay on a specific version, and our customers will often switch over for that reason. Another reason is that if you're stepping up for FedRAMP certification, which for a lot of organizations, businesses will need to do at a certain size, and when they want to work with the federal government as a client. And actually other large clients are starting to require not quite exactly the same, but similar processes where you will need to remediate CVEs within a certain amount of time. And your organization might need to provide a license agreement saying, yeah, we'll resolve all critical CVEs within a month. We'll resolve all high in 2 months, something like that. Very common requirement. When you need to fill that requirement, I would say definitely talk to us, because we can merely make that pain go away. And there's also some amazing value comparisons that our clients have shared with us that we've done, where basically sometimes we almost kind of pay for ourselves, because you can take an engineering team off of CV remediation and switch them over to something else. And we also really work with our clients very closely to try to raise the waterline and just get your security a little hardened in general. Okay. So I think there's a couple different value props there. Cool. Thank you. That's an amazing question. Thank you, Mac.
Any other questions? We have about 5 minutes left. If not, you'll definitely get an email with this recording, so you can always result back to it. If you have any other questions, you can always email me, kirby@chainguard.dev, and I'll direct you to the right person. And also be sure to sign up for next month. I have the link there in the chat for you for kernel independent FIPS images. Hopefully
they can actually hear you now, Kirby. I know it's not just me hearing.
Yeah, I think you all can hear me. Yeah, I think I'm on stage right now.
Yeah. Yeah, come to the kernel independent FIPS thing. It's very cool. And also, I'm leaving you here on the $6 million man. You can build it better and stronger. All
All
right.
right.
Thank you,
Well,
guys.
thanks everyone. Have a great day.